So that's dimensionality, and it probably looks a little bit familiar because if you're used to using units to help you with math, dimensions are a similar concept, except they're a little bit more abstract. And the way I usually like to define it is to say that variables have dimensions, numbers have units. So units aren't really meaningful, or not necessarily meaningful, unless they're tied to some sort of number. Variables can be meaningful regardless of the numbers you're using or the number system that you're using. So dimensions are abstractions, but units provide a very specific scale that will give the number meaning relative to that scale. Dimensions, on the other hand, give that number meaning relative to the nature of the system that you're working on. So units are scaled by an arbitrary standard measurement. There's usually some standard out there for every unit. The standard for a meter used to be a rod. I believe it was made of platinum. And that rod was 1 meter long, and everybody else had to, by that reference, say that is what the length of a meter was. I think they've redefined meter to be a property of light now so that it's more generically stable and you don't have to depend on protecting that rod. But the idea of a unit is to tell you what one means, and that's where the term units come from. What does unity or one mean? So the units are related to dimensions. And there's a reason that using units to carry through your calculations is helpful in making sure you're dimensionally consistent. Because they're related to each other. And you can think probably, what are some of the units we use for length? Just a few are listed here. We've got inches, feet, meters, kilometers, etc. Now all of these indicate a length ultimately, but there's several different ways to do that. So one of the beauties of thinking about dimensional analysis is you don't have to think about any particular unit system when you're thinking about a variable. You just have to think about it as a volume. It doesn't matter if the number is in feet cubed or meters cubed. Why is that useful? Well, U.S. hydrologists have to be good at converting units because our government has a particular system of units and our scientific community has a different system of units. So we have to be really good at converting those, and in the long run, it's easier to think dimensionally about our variables, and we don't have to worry about the units that way. Okay, so let's go through this example again, but think about the units that we might use. In terms of mass, an SI unit for mass is going to be something like kilograms. We could be using pounds. We know that pounds is a little bit tricky because pound is actually a unit of force, the effect of gravity. But force and mass are related to each other in a consistent way on Earth. So you can get away with thinking about force and mass equivalently as long as we don't move to different planets that have a different acceleration of gravity. So the units tied to our dimensions of mass might be kilograms. If we use a unit of length in SI units, we might have centimeters for a bucket. That might be an appropriate unit to use for the area of a bucket. So the area of our bucket might be centimeters squared. That is tied to the dimensions of length squared. And we might use centimeters for the depth as well, ultimately getting centimeters cubed tied to length cubed. Now this is pretty cut and dry, and it makes you think, well, units are the same thing as dimensions, right? And it's like, well, not quite, because we have lots of units for these things that have nothing to do with the length squared or the length cubed. For example, in hydrology, we might talk about larger areas of land in terms of acres or hectares. Now notice there's no squared in there. It's just acre or hectare. Now a hectare turns out to be 100 meters square on each side, but you can't tell that just by looking at the unit. So it's not really a one-to-one relationship here when you're thinking about units. Remember, these units are just telling you what one means. They're just giving you a scale. They're not necessarily telling you how that particular number is characterizing something out there in space, in this case an area. Same thing happens with volumes. We have gallons or liters that you can use. The dimensionality of those units is still length cubed. It's still a volume. It's just that the units of length are not going into that unit of volume. And it's another reason why thinking about dimensions is a little bit cleaner and easier than going back to some of the units that we might use in hydrology.